We will in this video we will see certain valves and valve basics. You are getting at least one question from the valves, basics, and their operations. If you go through the your APPSC and TSPSC previous automobile engineering paper, you will find one question from valves. Let us see what are these. So why is a poppet valve is so called? Why it is called poppet valve? The poppet valve derives its name from the motion of popping up and down. So because it pops up and pops down, that's why it is called poppet valve. Now, a poppet valve is sometimes called a mushroom valve. Why? What is the reason behind this? So normally, your poppet valve in its appearance looks like a mushroom. That's why it is called. It is due to its shape, which is similar to a mushroom. It is called, the poppet valve is also called a mushroom valve. So name different types of cylinder valves. So we have got different types of cylinder valves like poppet valve, sleeve valve, and rotary valve. Out of all these valves, poppet valves are very famous in their usage. Now, why they are used? Why poppet valves are mostly used in engines, right? So what is the advantage of poppet valve? Let us see. They are simple in construction, self-centering, they are free to rotate about the stem axis, and they have relatively easier maintenance of sealing efficiency, right? Now, why are inlet valves generally kept larger than the exhaust valves? This is a good question, friends. It was asked many times in your examination. So, the reason behind this is that speed of incoming air fuel mixture is less than that of the exhaust gases which leave under pressure. So, definitely, because your exhaust gas are leaving under pressure, they have less velocity or speed compared to the incoming air petrol mixture in case of your petrol engine, for example, right? Now, second one is because of pressure, density of exhaust gas is also relatively higher. So, because of the high pressure of the exhaust gases, its density, what is density? Mass by volume. So, because of this particular factor, because of the high pressure, so density of the exhaust gases is also relatively higher. This is another reason for using your bigger size of inlet valves compared to your exhaust valves. Okay, friend. Next, what happens if the valve lift is less than its optimum value? So valve lift has to be neither more nor less. If it is more, it is going to result in some problem. If it is less, it is going to result in some more difficulties. So what are they? Let us see. What happens if the valve lift is less than its optimum value? So because of, if the valve lift is less than the optimum value, there is some optimum value for the valve lift. If your actual valve lift is less than the optimum value, what is going to happen? It is going to result in the decreased volumetric efficiency. What is volumetric efficiency? By the way, it is the volumetric efficiency is the actual volume of the charge taken into the cylinder by the theoretical charge that occupies the cylinder volume. So this will be definitely approximately 98% out of all the efficiencies, friends. Your volumetric efficiency is the highest. Okay, so definitely it has to be more than 95% minimum. So please remember this. Now, what is likely result if the valve lift is excessive? So if it is less, it is going to decrease volumetric efficiency, and if it is more, what it is going to cause? It is going to cause excessive noise and wear. So that's why it has to be kept optimum. Now, this is a very, very important question. What are the commonly commonly used valve face angles for inlet valves? We are going to use two inlet valve angles for inlet valves. Okay, so they are 30 degrees and 45 degrees, but whereas we are going to use only one valve angle, one value only. So what is that? 45 degrees for the exhaust valve. So state the value of the commonly used face angle. So this is the face angle for the exhaust valve. Only we are going to use only 45 degrees. Now, what purpose is served by slightly varying the face angles of a valve and its seat? It is going to increase in the sealing of the valve. This is going to be very, very helpful. Okay, friends. So in this video, we have seen certain valves and valve basics from which you can expect one question. And also please read, friends, valve timing diagram, which is a very, very important diagram. So your exhaust valve and your inlet valve operations. How many degrees of the crankshaft your inlet valve is open, and how many valves of the crank angle, how many degrees of crank angle your exhaust valve is open, and also both of them closing. So is it before TDC or after TDC, or is it before BDC or after BDC? So definitely normally it should so happen that for each what you call inlet valve opening, inlet valve closing, and exhaust valve opening and exhaust valve closing should occur for 180 degrees of the your crank angle, but this is not going to happen. Why? Because they have inertia. Valves have inertia. So normally, so inlet valve inlet valve opening and closing, it is going to be more than 200 degrees roughly. I don't remember that value. And also similar friends, your exhaust valve opening and closing is also more than 200 degrees approximately. Please check the values for 2-stroke engine and also 4-stroke engine. So when 2 strokes inlet, your what you call a suction stroke and your exhaust stroke, your crank angles are more than 200 degrees. So definitely, so other angles, your compression stroke and power stroke, so for them the crank angles or the valve timing should be lesser than 180 degrees. So please check with any standard book friends. Okay, so in the next video we are going to come up with yet another important topic which is useful for your AMVI examination, automobile engineering for APPSC and TSPSC. Let us meet in the next video.